Good. Our topic today is the Raspberry Pi here on my left and how you can use it in your pinball machine, especially how you can use it like in addition to a pinball control system. We will go a little bit into it, why this is not like a pinball control system and why it is still useful, and what you can do with it and what you currently cannot do with it without further hardware. So the Raspberry Pi, this is like the Raspberry Pi 3, I think 3B. There are like four Raspberry Pis, Raspberry Pi 1, which is now available as Raspberry Pi 0. So that's very much the same. And then there was the Raspberry Pi 2. Those were, I think, up to 1 gig of memory. And then the Raspberry Pi 3, that's this one, that has already, I think, up to 4 gigs. And the new one has like up to 8 gigs, the Raspberry Pi 4. For like the purpose we're using it today, it really doesn't matter which Raspberry Pi you got. So you can use like the $5 Raspberry Pi Zero, which is like, it's awesome. And we're not going to run MPF on this Pi today. So we're just using this Pi as a port extender. And the reason for that is simply that the Raspberry Pi has like a lot of IOs here. I think it's 40 headers here. And we can use almost all of them as IOs, and they are pretty fast. So they can be updated at, I don't know, 1 kilohertz. Now I guess like even up to 100 megahertz or something. So really, really fast. So even compared to almost any pinball control system, that's a really fast inputs and outputs, which you do not necessarily need, but that's there. Yeah, hi Prospector, and thanks for subscribing. So you got the nice first batch. That's awesome. Thanks for that. Yeah, and I guess like most of us, or like a lot of people, simply got a lot of Raspberry Pis laying around. So if I had to count, I probably have like 5 or 6 Raspberry Pis just laying around, which I bought for separate for several reasons at certain points, and then they had a new one, so I bought the new one. I mean, it's like $25, and with a zero even, or just $5. thanks. And the Raspberry Pi, yeah, it's useful because it has like Ethernet, it has USB, it can use has HDMI for display, it has audio, which is okay on the 4, on Raspberry Pi 4. On the previous ones it's kind of bad, and they are powered by USB, and you often got some USB power somewhere. I think there can be also a camera here, and that's about it. But the beauty is really like the GPIOs here. And what we can do is, so let's look at what's available there. There's a nice page which is called pinout.xyz. So that's this one. And pinout.xyz, that's a page where they describe mostly just how the pinout on the Raspberry Pi works. But like, it's nice. So you see here, that's like my header from the left to the right. So we go back here. So that's from the left. So that's pin 1 here on this side. If we go back, and so that's basically all the pins here. So we got 3.3 volts power, 5 volts power. So those are the power out pins. And we got like a lot of GPIOs here. There are some ground pins, and some or most of the GPIO pins here, they also got some special meanings. For example, this one is also I2C1, and this one is whatever that is. And this is UART, this is PCM, SPI, PWM. So they got dual use. And what we can do with that is we can use those as inputs, but we can also use them as outputs. So all of them can be either inputs or outputs. and we can pull them up. So the Raspberry Pi will pull them to 3.3 volts, or it can pull them down to 0 volts, right? And if you pull it down, then you can use any basically device which pulls it up. So there are certain logic elements which pull the level up, and that's also possible with the Raspberry Pi. That's often not possible with traditional pinball controllers because they like it if stuff is pulled down. And that's also possible with the Raspberry Pi if you enable the pull up. And that's basically done in software. So you can tell the Raspberry Pi in software if this pin should be pulled up or down. So that's super, super cool. And you can also tell it where it's an output. And then you can set it to up and down. It's similar to pull ups and pull downs, and it cannot drive a lot of load, but it can drive like simple LEDs or any logic. And you could also connect like a FET or a transistor to drive larger loads. Even nicer, there's like a UART here, so it can do like serial communication with any peripherals you got. It can do SPI, that's serial parallel interface, so you can like write parallel stuff out. For example, if you want to interface the spike graph, that's possible with those kinds of outputs. It has I2C. I2C is like an embedded bus, and there are a lot of chips. For example, I got one here. So this one is like a servo. This is a USB I2C controller, but this one is from a controller from Adafruit. It can control servos or PWM, 16 ports, and is controlled via I2C, for example. And you can connect that to a Raspberry Pi and control it. Then there's more, but I guess those are the most important stuff if you want to connect peripherals. And in MPF, we can actually use it to control servos directly. So you can use any GPIO on the Raspberry Pi for a servo signal. So that's, I think, I don't know how much this really is, like 24 servos or even more. And that's super awesome. That's super accurate because, again, this can drive outputs as a super high resolution. It can also do like super fast PWM and stuff like that. So that's something which the Raspberry Pi can do. This is like the general pinout. There are some differences between the models, which are also listed on this page, but this is basically available on all of them. So that's a useful page if you just want to see where to put stuff. So for getting started with MPF and the Raspberry Pi, we got documentation. I tried it today. There are 2 slight mistakes. I will push a fix later. On your PC, you have to install a library. It's called pigpio _MPF because we forked it because it contained some bugs and upstream didn't want to fix it. So we forked the library, and we maintain it now for you. And you have to install this on your PC. Then that's it on the MPF side. So you can have MPF on the Pi as well. Then you have to install it on the Pi. But if you run it on your PC, then like I do, then you have to install it on your PC. Additionally, there is a daemon. It's called pigpio, and that's basically a daemon which controls the GPIOs on the Raspberry Pi. And the beauty about it is that it uses like the Broadcom driver stuff. So there are like ways in Linux where Linux can control GPIOs, but that's not necessarily like a fast interface. It's more for status LEDs and simple stuff. But this really uses the Broadcom low-level stuff, which is really, really fast. And there's a daemon which is luckily maintained and inside the Debian repository. So any Debian-based systems like the Raspberry Pi operating system, Debian, Ubuntu, whatever you want, it's in the repository. You can install it via apt. And it's really those 3 lines, and then it works. There's one additional thing which I found out earlier when I tried it. First, look at this setup. So what do I have here? So I got like that's my card reader. That's what I use to flash the card. Maybe let's start in the beginning. So what did I do first? So first I used a program. It's called Raspberry Pi Imager. Let me switch over here. That's the Raspberry Pi Imager. You now see it in German, but it works the same in English, I guess. So you choose your operating system here, and I chose like the Raspberry Pi operating system, and I went with like the Lite, the Raspberry Pi Lite version, because I do not need like a UI interface on the Raspberry Pi. So I used that one. I selected my SD card. Now it's not plugged in. And then you click write. That will create the image. Then one thing you can do is you can put like a file called SSH in your boot folder if you just mount the SD card, and then it will automatically start an SSH server. That's very useful if you do not want to connect connect like a keyboard and a monitor to the Raspberry Pi, right? That's what I did. And then I just used SSH. I went into my wireless router at home, checked the IP which Raspberry Pi got, and then I SSH'd into the Raspberry Pi. There are other ways, right? You can also connect like a monitor and it will show the IP on startup, for example. Or you can set it permanently. There are multiple ways how you can do that. But that's how I did it. So then I SSH'd into it. I ran those 3 commands and like the one change in the init file. And that's what I did. That's really what I did on this Raspberry. So I installed it like 2 hours ago, just to have like a clean image to see if it's actually worked. And yeah, I found out that documentation wasn't just right. And then yeah, you put in the SD card into the Raspberry. That's it. So what do I have here? So I connected like 2 switches here. So those switches go to the GPIOs 7 and 8 here. And I also got like ground from here. So that's the ground pin. Ground pin, I think it's 6. I think it's 1, 2, 3, 4, 5, 6. Yeah, 6. And so those inputs, they pull those pins to ground if I press them. And then I got 1 pin here. That's the 2nd pin, and that's also ground. So this is like an LED which I connected to an output, which we configure as output. And that's basically one way to see if an output works, right? Additionally, I connected a servo. It's a small tower servo, like those $1 or $2 cheap servos from, I don't know where I got that actually. I think I got it from Amazon, but you can also buy them from Hobby King or like your favorite RC shop. And that's connected to 5 volts here. It's not for a test setup, that's okay, but that's not something you would do like in a professional setup where you would power it separately, right? Also it goes to ground here and it goes to some output here. It's the 2nd one from the bottom left, and that's then the servo. Now we can check the pinout again. So the servo is connected here, the inputs are connected here, and the output is connected on GPIO 2. So 2, 7, 8, and 26 should be. Next we have to do is we have to tell MPF about it. So what I did is I used my usual machine, which I always use on stream, and added like a new Raspberry Pi file. So first I configured the hardware platform here. It's RPI for Raspberry Pi. That's the hardware platform you have to use. Then there's a Raspberry Pi section where you put the IP. In case that you run like MPF on the Raspberry Pi, put localhost here. Otherwise, put the IP of the Raspberry Pi here. So that's 10.10.0.22 in my network here. And the port is 888, and my IDE is telling me that it's the default. I wouldn't have to put it here. And then we configure the switches, 7 and 8, right? This number is just the GPIO number. It's not the pin number, it's the GPIO number. The Broadcom GPIO number is how it's called. So that's those GPIO numbers here. Those are technically the Broadcom numbers. Yeah, and then I got one more switch, which I tested earlier. And then I got one output on pin 2, which defaults pulses for 1 second, and it pulses on an event. I will show you that in a minute. And I got a servo on 26, and I put some test positions here. And now we can actually just run it to see how that turns out. So we run MPF both, so for the media controller and the MPF game engine, and we see that all switches here are active for some reason. So probably read them initially, and now we will go to that view. Now you see everything twice. Yeah, like that. And now I can press the. Okay, it needs the first input to find the switches. So I can press the. Now you can. Should have put it differently. A little bit. Okay. So I can press the switch, and you can probably hear me pressing it, and you can see the input turning green here. And press the other switch. It's also working. Those inputs are working, and I can now also trigger the output. I think that's key 1, and you can see like the LED turning on for 1 second. So we can drive the output with PWM. It's super accurate. So this is done in the pigpio daemon. So like the how it's called, like this software which runs on the Raspberry Pi actually does the timing, so that's super accurate. And we can also like control the servo. So you can see it can turn. And my DMD does, or my segment display does nice animations, which are now fixed, so they work. So basically, that's what you can do with this. Additionally, like there's more. So you can, as I told earlier, you can connect I2C. If you want to do that, you can do that using those outputs. There are 2 I2C on most Raspberry Pis. I'm not sure if it's the same on all of them. That's something to check per Raspberry Pi, because like on this pinout here, there's only 1 listed, so it's I2C 1 on those 2 pins. But I think like on some Raspberry Pis, there's like more than 1 I2C you can use. You run your first pinball machine with Arduino Megas and homebrew driver boards. Yeah, like okay, Arduino, that's tricky CPU wise. So like if you want to run like MPF on a Raspberry Pi, that's possible in my opinion, especially like on the Raspberry Pi 4. I wouldn't do like on earlier ones like mine, like the Raspberry Pi 3 I got here. It's on the edge CPU wise. It works, but it ain't great. With Raspberry Pi 4, that's definitely fast enough to run a game. You probably cannot do like a lot of video stuff. So if you want to run like multiple videos at once, that will probably cause lags. But you can run like 1 video or sometimes some video if you're careful with your resolution, right? cannot do 4K. You might be able to do full HD, but I would stick to 720p or something. That would probably be not such a problem, right? Because I mean, you can do full HD, but then you would have to do more tuning, like more tuning on, for example, on the video encoding and so on. So that has to be right, otherwise it will be lagging on the Raspberry. Sound won't be an issue. That will work on MPF itself. The game engine also is super fast on the Raspberry. That's also not an issue. So you will fight like the media controller a little bit, but that's totally possible. If you want to turn the Raspberry Pi into like a pinball controller, that would be like a little bit more work to do, because currently the pigpio daemon, that's like this one here, that's the library we are using. It can do a lot of stuff, as you can see here, even more stuff than we are actually using. And you can also see like the pins, which are, or how they are mapped on different like Raspberry Pis here. That's something which I would check, for example, for if I wanted to use like a separate S2C or something. What it can do very precise outputs, very precise inputs. But it can't do is like hardware rules. So like in most pinball controllers, you got this, when this switch triggers, trigger those up this coil, right? Like for example for flippers. And that's something which this does not support. I mean, it wouldn't be very hard to like write a small C or Rust program to implement this on the Raspberry Pi, but it's simply not done at the moment. But if you want to do that, that's possible. And there are also like some manufacturers which actually do something like that. So it's totally possible. The Raspberry Pi, as you probably know, can also do like it can run like serial LEDs, so WS2811 or 12, or also any other kind of serial LEDs. There are libraries out for that. That's also something which is not supported in this library, and we currently do not have that. But if you want it, we can totally make that happen in MPF. That would be relatively easy. I mean, not super easy, but relatively easy. Same for like for any other hardware which is available on the Raspberry, right? There's also a platform in MPF for, it's called, what's it called? Raspberry Pi DMD. It's a different like project where you can actually turn use the Raspberry Pi to drive those China DMD panels, right? The same ones which are used in the fast DMD or on the Pinto DMD. So that can be directly driven by the Raspberry Pi with like a small PCB to interface it. That's also something which is available. Not sure if you can use that together with MPF, because that might be a little bit CPU hungry. Not sure. But like the cool thing about the Raspberry is that there are so many, that it got so much stuff on board. So that's why it's super cool. Yeah, I mean, really, like, you can do it on Raspberry Pi 4. But still, very important, do like the development part on an ordinary PC. I would not recommend to like use your Raspberry Pi as a development platform. So do this on your PC, use your Raspberry Pi remotely or simulate your game, because like you won't be able to run a proper IDE, and like all the nice debugging stuff isn't available or is very slow with only 4 gigs or 8 gigs of memory. You probably want more for that. Yeah. You want a fast PC. That's just developer ergonomics, I would say, because like Visual Studio Code, what I got here, that probably hardly starts on the Raspberry Pi, and it's very useful. So that also works. One more thing which you can do is you can also control steppers with the Raspberry Pi. So those are small stepper drivers. They are like, I don't know, you can get like 6 of those for I don't know, $10 or something. They are cheap. And what MPF supports is like MPF can bit bang the protocol which is needed to control the stepper via one of those. This is usually a bad idea on most pinball controllers because the output granularity on those is like 1 millisecond or something, or 2 milliseconds. So it's super slow. You can drive them at 500 hertz or sometimes even only 200 hertz. And like a stepper needs a lot of pulses. But on the Raspberry, where you got like a resolution of multiple 100 hertz, that's totally feasible. So you can use those on the Raspberry on a normal output to drive steppers. So theoretically, you could also use this to drive like 24 steppers or something. So that would be a lot of steppers, but it's totally possible. It's also something which is not available on a lot of hardware. Yeah, if you want to have like analog inputs, that's not available on the Raspberry Pi, but there are again like I2C or SPI chips, which can be interfaced with Raspberry, and then you can have analog inputs as well. So that's the cool thing about this. It has so many interfaces, and you can interface anything with the Raspberry Pi. So that's why I like the hardware, or like the board, and it's cheap, especially like if you think about a $5 Raspberry Pi Zero, which you can then interface via serial. I think pigpio daemon can also work via serial, so you can connect the Raspberry Pi Zero via USB to your, I don't know, whatever PC you're using, and then you got some additional output somewhere in the machine, or an additional I2C. So yeah, you can, didn't show that right, how you can configure I2C, but it works like any I2C in MPF. So basically how this works is you can configure, for example, you would say I2C, and you set it to Raspberry Pi. And now I can have like the servo, called servo controllers. I think that's the that's like our I2C servo controller. So you can configure those, and then you would set like servo 2 to platform I2C, and with that you can now have like a number, like the address of the controller minus the servo. That's how that works. How you would configure like we can look it up, but I2C platforms, and yeah, so we would put okay, the default is obvious, is for some reason 63, so it would look like 63 0, and we put I2C servo controller here, and we probably have to do servo controllers, Raspberry Pi, and I2C servo controllers. And now we got two types of servo controllers here, which one maps to the I2C of the Raspberry Pi and then to the controller, and the other directly maps to the Raspberry Pi. So this one would be by default mapped to the Raspberry Pi because it's the first servo controller. And then both servos should work. I mean, I didn't connect it now, so it won't work. But yeah, that's like, this one has like 16 servos. You can do 16 servos or any any PWM. So some manufacturers use this chip to control their backlights, for example, or GIs, because it can dim lights with like 10 bits resolution, which is really nice. It's a lot of resolution on the PWM range. So yeah, this one is available from Adafruit. It's, I don't know, $15 or 20. It's quite cheap. There are also like accelerometers. Like there's a lot of stuff on I2C. And yeah, that's what you can do with a Raspberry Pi. I mean, you got any more questions about that, feel free to ask. That's what I wanted to show. That's my small setup here. Today, like as an experiment, I thought I would like not do slides because it feels like it feels so academic, right? So I did a PhD, so I went to a lot of scientific conferences and saw a lot of boring slides. But that's why I'm used to slides, and I wanted to see how it is if I do not do slides. So yeah, feedback on that is welcome. So if you like slides in the beginning, or should I leave them out? Yeah, I mean, you can write it now, or you can write it later in the comments. That would be welcome, because yeah, I do this partially for me, so I can try stuff and improve stuff because I tried again, but also mostly for you, so that you learn something. And yeah, let me know if it's better to have like some slides where I got some diagrams or such, or in an agenda in the beginning, like you do in a professional talk, or if you like it better if I just show the hardware and we go into the stuff together. Yeah, so that's a question for the comments. Yeah, so yeah, like let's so I can wrap up the topic a little bit. So like what I showed is like really Raspberry Pi, great hardware for like small features. You could put it into a topper, you could put it below the playfield. I mean, this is like one way to use it. There are like more ways. You can also like write a small program which runs on the Raspberry and use it as a display. Like for example on Spike, you got those small, like they call like mini displays, like on Ghostbusters, and you could do like something similar with Raspberry Pi, right? Connect it to the HDMI and have it like just play pre-recorded sequences or such. Theoretically, you could also run like a second media controller on the Raspberry Pi to play like some videos via the media controller. That would also work, and it's one way. Or you can simply use it to interface like rotary encoders, servos, steppers theoretically, or yeah, or more inputs. If you need more inputs, it's probably cheaper than buying more boards of your favorite pinball controller, right? I mean, if you just use it for server switches, I don't know. There are like multiple options, and we are homebrew, so we can do anything. In my Good Brothers Evil, actually do not have a Raspberry Pi at the moment, so we got like a lot of boards in there. That's probably also one of the things which we will simplify. Because, for example, we got 2 of those in there for exactly 1 servo each. It's also like with this R2C USB controller here, which is actually just a tiny Atmel a tiny 85, so it's like 20 cents chip, which kind of can do USB with like some special firmware, and I use that as a I2C to the USB interface. But like the Raspberry Pi would be nicer than this, for example. Then we also got accelerometers again with this same I2C chip. It's also not great, so we try to use them as tilts, so like as 2 separate tilts, but it's not working too well, to be honest. Probably need to do some tuning there, or maybe we will also turn to some like traditional tilts, because they are what players expect. And yeah, like then we got like, let me think, yeah, 3 fate candies in there, and yeah, like a lot of boards. And maybe we could simplify it. I mean, in a production machine, you would certainly simplify this by large magnitude. It's a homebrew, so we bought like all of the boards. So we got multiple servo controllers, multiple controllers for everything. I'm in my machine. Yeah, I mean Cobra Pin. I got Cobra Pin like on Saturday, so it's not in my machine. And I got currently we got the fast system in there. We had the P-Rock in there initially, but back then we had some bus problems, and then we switched to the fast system for that reason. Because I mean we solved this problem later, but at that point we didn't quite understand it, and we wanted to move on, so we switched the hardware. Sometimes you have to make decisions, right? And that's why the fast system is in there. But I guess like the P-Rock system would, or the P3-Rock system would work equally well in my opinion. Even like the Cobra Pin, I mean we probably would need like 2 of those, but it would work. I also got like an OPP system, like the old one I showed them on stream earlier. That also would work in our machine, I guess. So like from the number of inputs and outputs it has, it would work. We did never put it in there, to be honest. So because like the fast system then just worked. I mean, also had issues there because we ran over their switch limit. Nobody before actually tested more than 128 switches on that system, and we were the first using more than, or trying to use more than 128 switches. They fixed that in firmware and it's working now. But it's like, if you got more of everything, then sometimes you're the first trying the stuff. And I don't know, like, yeah, some mini display would maybe also cool. That's the problem. Yeah, you can do so much stuff, but your time is limited, and you also need to build a game and then make everything happen. And now we actually got really slow because now we are finishing stuff, and that's only baby steps, right? Then you do like all the graphics like the third time now, and now we're printing it and putting it on the playfield. So you have to disassemble everything and then reassemble everything. That will take at least 2 full days, and since we're not doing it like full time, it will take us like 4 evenings or something to disassemble and reassemble, maybe 6 or 8. And also in between it needs to be printed, and that's also kind of expensive. I mean, printing and clear coating one playfield is roughly, and having it produced professionally and printed and clear coated is like $1,000 roughly for one playfield, 2,000 for 2, which is why we went for an overlay initially. And then if you do it professionally, then it has to be perfect, right? So you do not want to have any mistakes in your cut files, in your printing, because I mean, most people won't see it, but you will see it. That's the problem. And then we will redo the ramps probably. We did them, I think, 3 or 4 iterations. So not all of them. Some are only in the second or third iteration, but some are also like in the 4th iteration because it wasn't as smooth as it should be, nor it was jumping somewhere. So we redesigned and then reproduced like all the metal stuff from like a metal supplier which lasers the stuff for us, and then we reassembled. And we probably will do this also once more, and then it has to come together again. Then we also have to print the cabinet outside. So we did, like, we had an artist make like new graphics for everything. So we will also reapply the print on the cabinet, and therefore it has to be also like improved a little bit, sanded and so on again, and then it has to be glued on there, and therefore you have to assemble, basically remove everything also. So a lot of stuff, and I hope we will get this done this year, and then next year we will do like the new machine. So we already got everything for the new machine, and too many ideas to put in there, to be honest. but we will like do a new machine, like a simple machine, only one player, but probably a few tricky mechs. So we will like do some trick shot stuff with a lot of ball routing and a lot of subways for mechs. So we want to do a portal theme, so where you shoot into one ramp and it comes out the other ramp, but like faster if when it made it through the ramp, right? So like if you know the Portal, the Half-Life game Portal, like that you shoot it in here and it comes out there and instantly, and that requires like a lot of magic mechanically to route the balls, right? So they have to disappear magically. I mean, if you got a trapdoor, you can do it once, but it has to be feeded somewhere else, and then it has to reappear somewhere else. So there has to be a ball staged and so on. And you have to have, or we want to have like multiple locations where they come out and in. So it gets tricky mechanically, and yeah, there it has to be reliable then. And so there are a lot of challenges. Let's put it this way. And it also has to be fun and should be fun more than one time. That's also sometimes a challenge. Yeah, and in our game, it's like the head-to-head game is simple because you're playing against somebody else. So it's a flow game. So there's no ball stopping. That's bad for you because then your opponent will be ahead at some point. And yeah, maybe we'll stream it. I mean, we will do this earlier, right? So it will be earlier in the evening in Germany. So we will meet in the evening and then do like 3-4 hours of building. Sometimes also not building, just drinking a beer and eating some food. But yeah, maybe we can do that in the future. Maybe it will be interesting as a recording for some people then, because we can. Yeah, I guess like the European people can join, and for the US people it will be a little bit too early. We would probably end by end by half an hour ago. So usually I go home at 10 or something, and then it would be like 6 p.m. to 10 p.m. or something roughly. And yeah, maybe. I mean, yeah, it's if you stream it, then you have to have some clue, right, what you're doing. And we're sometimes pretty clueless there, and we just meet, and sometimes we also just play pinball. So that's also something, but we're not professional players like others. So that's we have to see. Maybe. Maybe we can show something like when we actually like assemble a playfield or unassemble stuff. That's interesting. Have to like find out how we mount the camera, but that might be interesting. And like other stuff, I mean, sometimes we make stuff from wood or stuff like that. It's not super fancy. We're not professional engineers, like mechanical engineers. We are like, I'm just a computer scientist. I'm not not a real engineer. Some people would say, even if I've got a degree in engineering, but I'm not a professional engineer. So sometimes we do stuff and we still learn. So it's probably funny to watch us fail. So why not? So yes, that's it for the Raspberry Pi for today, and hope you enjoyed my short show on this Raspberry here. Hope this actually looks good, but at least in my preview, it looks much better than the previous times. And I hope you liked it. Maybe learned something, and especially if you want to use the Raspberry Pi, you got my take on it. I'm not like an expert, but I'm currently like building a kid style game with like a Python game, which we will hopefully produce soon for in older games, so like in a kit which you can buy similar to Bride of Pinball 2.0. And that's also running like on a Raspberry Pi 4. So I did a lot on building like images for the Raspberry Pi. That might be also something to do a stream of, but it's super special. Like it's like building embedded software, and that's not something you do as a hobby usually. It's like it's a lot of engineering and so on, where you like really put a lot of time into the last, like let's put it like last 10%. And that's which something which you would do like really at the end, not in the beginning when you still build the game. And that's like there we're finishing up the game, tuning stuff. And the Raspberry Pi is definitively fast enough. I actually tuned the game that it worked on this one. That's why I got this cooler on here because it got really hot. And that's really that ran on this one. It's a little bit on the edge. Boot times were a little bit long, but on the Raspberry Pi 4, even boot times, it's like 10 seconds into MPF with running media controller. That's totally possible depending on your assets, but the boot time of the Raspberry is like, yeah, sometimes 6 seconds or something with graphical interface. So it's possible to do a production game with it, but it will really require some tuning at the end, like finishing, engineering, and so on. But if you're willing to do that for a production game, it's possible. I would, as I told this before, right? I wouldn't recommend it to do this in the beginning. Do it later when your game is finished, and develop on an ordinary, boring PC where stuff just works. That's just my take on it. Yeah. So thanks for joining in. Thanks for chatting. Have a great evening, and yeah, have a great remaining week. Keep on hacking. Yeah, keep me updated on your Raspberry Pi setup. I'm always interested in that. So also, like if we got something which we can document for everybody, that's always useful to have that. Even if it's just a starting point, like we got in a tutorial in the docs where how you install like Raspberry on yeah, and then make it ready for the Open Pinball projects or something. It's not super scientific and it might break in half a year, but it's a good starting point for new users. And so this is useful, and a lot of people ask about the Raspberry Pi, so that's definitely cool. And I hope this will be like, I'll probably cut the last half an hour of this video, but like the beginning will be like a tutorial video on the hardware platform and like how you use this and yeah, how it looks in action. So yeah, that will hopefully be useful for future users, and they will then watch it in the documentation. So thanks for being part of the tutorial then, or the documentation. Have a great evening, and see you soon.